Good afternoon, students. Please confirm whether my voice is audible to all of you. Yes, there is a small change. Ma'am is on leave, so that's why I have assigned to take your class. So let me know how many experiments have been completed in your workshop lab till now. If I'm audible, please let me know how many experiments have been completed in your lab.
7, sir.
Okay, good. So today we'll try to complete experiment number 8 and 9 because both are interconnected. Okay. And also we are having very less number of classes ahead. We have to complete all 11 experiments. So that's why I will try to complete experiment number 8 and 9 in this lab. So particularly these two labs are interconnected and also there is no observation part, only demonstration of electrical power panels. Okay. So that's why we'll try to continue and complete both experiments. All I need your concentration. Please focus on the descriptions and also demonstration. So let us start with the experiment number 8. Then after completion, we'll continue to experiment number 9. Basically, the objective of experiment number 8 is demonstration of various components in electrical power panel. So mostly in experiment number 2, you have studied the domestic wiring. That in that case, we are using very nominal protection like MCBs, MCB and fuses. They are being used for protection purpose because the domestic loads require very low current and domestic power demand is very less, and also that is operating in single phase. So that's why we can simply rely on those small devices, protection devices. But while you are considering the industrial wiring or any commercial building or bulk consumers who are consuming who is having heavy loads which will draw more current, high current, and power consumption is high, mostly the power supply is in three phase, not in single phase. That case, we have to go for some additional protection features, some additional control features. Okay, so for that we could not use the normal main switch what we are using in your home. If you see in a domestic wiring, you will find the service wire is coming to your home, and the first element is your energy meter. After energy meter, there is a main switch. Okay, inside main switch, if you open, you will find two cutouts are available. Okay, Mm, but same panel could not be used for three-phase supply. We require special arrangement for protection as well as control regulation. So for that, we require electrical control panel or power panel. Okay, so how this power panel will be designed, what will be the components of this power panel, and how you will operate those loads, and how this power panel will help you to just protect different kind of scenarios, protect the devices or equipment connected to the particular supply. So that we'll study in this couple of experiments. So let us start with the experiment. The components, particularly the apparatus, are only the components which are used inside the power panel or control panel. Okay, so mostly the outer cover of that power panel is an enclosure, which is simply looking like a almirah, or what you are saying, a cupboard. Okay, then next one, next you will have some measuring equipment like voltmeter and ammeter that will be there to just acknowledge you how much voltage and current is entering to the circuit. Similarly, there will be some selector switches just to provide switching between the load and the supply during the healthy condition. If there will be any unhealthy condition, any contingency, that will be disconnected automatically. Okay. Then some indicating lamps will be there using LED. Some switch, push button switches will be there for starting and stopping the devices. There will be some power conductors. Some relay will be there which will sense the current or temperature and also loading of the machine. Then there will be some timer which will just coordinate between these control units. Then there will be certain fuses for providing protection. Then to just alert the worker or the operator, there will be an annunciator. Similarly, there may be some human machine interface and all those things. Okay, we'll discuss one each component one by one. Let us start with the enclosure of the particular power panel. So power panel, if you see the left side of this a diagram, you will find there is a simple cupboard type yeah, device is there. It's not a device; it's a just enclosure, known as enclosure. It's just looking like a metal cupboard. Okay, so inside that, all the equipment, particularly the uh, conductors, the relays, the uh, bus bars, they will be arranged inside it. Okay. So particularly this enclosure is a physical barrier which provides housing to all these protecting equipments and connecting equipment. Okay. And also it provides some kind of barrier between the atmospheric things or the ambient with the internal part, because if you look, it will be simply connected openly, just like we are going in domestic wiring. So what will happen, the dust accumulation, humidity, then temperature variation, there may be some uh, direct contact human and or animals to this panel. So that's why we normally use a enclosed chamber for arranging all those, and that chamber is known as enclosure. Next, to just observe what is the real-time value of voltage and current flowing through the particular circuit. We exactly require ammeter and voltmeter. So if you see here, and the right side diagram, you will find that this is a connected power panel where you will find there are some components connected inside the enclosure, and some is also available backside of the front door. Okay. So particularly if you see this box type structure, it is simply a annunciator, which it is being mounted on the um, front side front panel of the particular enclosure, and these are the indicators, LED indicator. It will indicate the running condition of the devices, and these are the push button switches, the back side of the push button switches, and these two are the voltmeter and ammeter, analog voltmeter and analog ammeter. Okay, for display purpose. And here if you see, there are some bus bars. Here one bus bar is maintained, one another bus bar, here another bus bar is maintained. And these bus bars are being arranged with some conductors. Some conductors, and here all these, yes, here the conductors are available. Again, some timers and also some fuse arrangement. There you will find so many cartridge type fuses are being used just for protection purpose. And if you see here, there is a small blower or fan is available. So exactly the supply to the industry will be 24 into 7. And if the industry runs for whole day and night, so definitely there will be huge amount of heat will produce in this circuit. And just to give ventilation, proper ventilation and cooling of this device, so what happens, this blower is continuously running, and there is a thermal sensor. It will sense the internal temperature, and while the temperature will be more than the normal temperature, so what will happen, it will just switch on the fan, and this fan will blow out the all hot air from this chamber, and there will be a cool ventilation from the outer side. Okay, so some holes are there, so outer air will come inside. I mean, cool air will flow inside, and hot air will being exerted by this particular blower. Okay, this fan, just like this fan. So now we'll come to the individual components. So this is the right diagram just shows the front panel of the let's say control panel. Okay, front one. So here you just see there are voltmeter and ammeter analog type. Okay, and if you will see, this voltmeter and ammeter will show you the real time voltage and current which is flowing through the circuit. At any time you can get the information directly watching this one. But thing is that if you see the industrial wiring or bulk consumers or commercial building like malls or cinema halls, or if you go for any apartments. Okay, so those supply takes three phase. Suppose the power requirement is three phase, because there will be some three phase load. In that case, what happens, the current and voltage should be measured in each phase and each line. So for that, single how to use how to measure all those parameters using single meter. So for that, there is a special arrangement with the uh, selectors. So these are the selector switches. Okay, on one voltmeter selector switch will be there, and one ammeter switch will be there. Ammeter selector switch that will be connected very close to this. So if we want to measure, just like here they are available. Okay, so what you need, one volt ammeter selector switch will be exactly close to the ammeter. So if we want to measure the current of line 1, there will be 3 lines, three-phase circuit, 3 lines, R, Y, B. Suppose I want to measure means R line current, then I will simply switch this I mean your ammeter selector to terminal 1. So what will happen? It will just switch to line 1, and line 1 current will be measured by this ammeter. Whatever reading is coming, that is line 1 current. Similarly, if you want to measure the line 2 current, then it should be changed. The knob should be changed to terminal 2. Similarly, to get the third line current, just change the terminal to knob to terminal 3. Accordingly, we'll get line 1, line 2, line 3 current in a different instant by just switching or selecting the ammeter switch. Similarly, to get the voltage measurement of three-phase, line and phase, we also require one voltmeter selector switch that is available here. Just see it is off condition. While we will need to measure the line to line voltage. Suppose I want to measure voltage between line 1 to line 2. So I will just move this knob to this one. Just see it is written L1, L2. So it will give this point will just help you to measure the voltage between line 1 to line 2. That is line voltage between 1 and 2. So that will be shown here. Similarly, if you want to measure the voltage of line 2 to 3, line voltage between 2 and 3, that is RYB. So that will be measured through this point. Again, if we change to this one to line 3 to line 1, then it will also measure RBY like that. Then if we want to measure the phase voltages, again there is a facility this side. You just see line 1 to neutral, that is phase 1, line 2 to neutral, phase 2, line 3 to neutral, phase 3. So all the three phase voltage could be also measured by simply using this selector switch. And again, just to give you acknowledge whether the power is available, whether the machine is running. So for that we need some indicating lights. So that's why some indicating lamps are used, particularly LED lamps are used with different colors like red, orange, green. Yeah, as you can see this panel having so many indicating lamps are available. Okay, so that will just acknowledge you whether the current is available in the circuit, whether the machine is running or not. Suppose this is this, while this green light will glow, we can say yes, current is available. And while this green light is running, suppose this is dedicated for one machine. So whether this machine is being energized, this green line would be available. If the machine is stopped, so this yellow light, you can say the orange light will be there. And if there will be any fault, this light will glow and it will show that no, there will be some fault, or sometimes some annunciator will announce that one. Okay. So particularly this upper half, it is all LED lights. And if you see these lower green and red bottoms, they are the push button switches. Okay. The push button switches are being maintained for switching on and off. So green for on, red for off. Just it is written here, green 1, red 0. That means if you want to switch on the motor, we'll just press on this button. And if you want to switch off, then press on red button. These are the push button switches. For high voltage operation, we normally use these push button switches with proper insulation that will provide little bit safety and also smooth operation. Okay. So some other kind of push button switches are also available for different regions, different loads. Then we'll move to switch fuse units. So mostly what I was talking, you may have this type of main switch in your home for domestic purpose, where you are finding that there are only two this cutouts. If you open that main switch, there will be a handle like this. The main switch will be there. If you open, you will find only two cutouts because we are getting single phase supply, one phase wire and neutral wire will be there. So that's a two cutouts will be there. And if you are going for three phase supply, so definitely for 3 lines we require 3 fuses, so this will be available, but this is not reliable because while there will be some unwanted situation, some overcurrent will be there. Because of that, what will happen? What is inside it? There is a fuse conductor, and that is a low melting point based metal. So what will metallic conductor? So what will happen if there will be high current flowing through the circuit, or there will be any short circuit in the load side? So what will happen? Low means it will draw more current. So because of that, here I square R into T amount it will produce, and this will achieve the melting point of this conductor, and this conductor will simply melt down and isolate the circuit. But instantly we could not restore the circuit. Why? Because while it will be melting down copper metal. So definitely this part will be overheated. So we have to wait some time. After that, we will connect again the fuse wire and again the system will be restored. But this may be suitable in our domestic purpose. In our house, if current will be stopped for 2 3 minutes, it's okay. But in industry, all the entire process is going in a sequence. So batch wise, it is producing. That means the raw metal enters in one end and the finished product gets out in the other end. In between, there are continuous processes. One process will do some modification, second process will do some modification. If we are going to stop the machine for some reason because of the fuse for 5 minutes or 10 minutes, so definitely that will hamper the entire production process. So that's why we need instant restoration. So for that, instead of using normal this means the molten fuses, you will use this cartridge fuses. These are the cartridge fuses. Okay, instantly while there will be fuse, it will blown off inside. So simply you just replace this cartridge and again connect a fresh fuse cartridge. Okay. So this is the panel now. In place of this, we are using this one for three-phase cartridge type fuses, and here the fuse has been loaded. Okay. Apart from that, there are some other type of fuses available. You may have seen this type of blade type fuses are being used in a car or your bikes. Okay, you will find this type of fuses. And this type of fuses you might have seen in case of your grinder, mixie. Backside of that, you will find this type of fuses are there. Okay, so different type of fuses are there. You can just get the idea from this video. I'm just playing this one. Just make me acknowledge whether the voice is audible to you or not. Please confirm whether the audio is audible to you.
Yes, sir.
Sir,
Yes, please.
so ऑडियो नहीं आ रहा है.
Okay, let me again reload this one. Let me again share this one. Okay, I'm just stopping and sharing.
DC fuses are there are different
Is it
types
okay
of
now?
fuses available in the market, and they can
Yes, sir.
be categorized on the basis of different aspects. Good to know, fuses are used in AC as well as DC circuits. In this video, I'll go to show you different types of fuses. Fuses can be divided into two main categories according to the type of input supply voltage. Number 1. AC fuses. Number 2. DC fuses. AC and DC fuses. There is a little difference between AC and DC fuses used in the AC and DC systems. In a DC system, when the metallic wire melts because of the heat generated by the overcurrent, then ARC is produced, and it is very difficult to extinguish this ARC because of DC constant value. So in order to minimize the fuse earthing, DC fuse is a little bigger than AC fuse, which increases the distance between the electrodes to reduce the ARC in the fuse. On the other hand, for example, in the AC system, voltage with 60 Hz or 50 Hz frequency changes its amplitude from 0 to 60 times every second. So AC can be extinct easily as compared to DC. Therefore, AC fuses are a little bit small in sizes as compared to DC fuses. Fuses can also be categorized based on one-time or multiple operations. Number 1. one-time use fuse. Number 2, resettable fuses. One-time use fuse. One-time use fuses contain a metallic wire which burns out when an overcurrent, overload, or mismatched load connect event occur. User has to manually replace these fuses. Switch fuses are cheap and widely used in almost all the electronics and electrical systems. One-time other types of fuses. Curtis fuses. Curtis fuses are used to protect electrical appliances such as motors, air conditioners, refrigerators, pumps, etc. Where high voltage ratings and currents required. They are available up to 600 ampere and 600 volt AC and widely used in industries, commercial as well as home distribution panels. There are two types of Curtis fuses. Number 1, general purpose fuse with no time delay, and number 2, heavy duty Curtis fuses with time delay. Both are available in 250 volt AC to 600 volt AC, and its rating can be found on the end cap or knife blade. Blade type fuses. This type of fuses, also known as a spade or plug-in fuses, comes in a plastic body and two metal caps to fit in the socket. Mostly they used in automobiles for wiring and short circuit protection. Other types of fuses like SMD fuses, XL fuses, thermal fuses, high rupturing capacity fuse, and high voltage fuses. Resettable fuses. Resettable fuses is a device which can be used multiple times without replacing it. They open the circuit when an overcurrent event occurs, and after some specific time, they connect the circuit again. Polyimide positive temperature coefficient device (PPTC), commonly known as a resettable fuse. Polyswitch or polyfuse is a positive electronic component used to protect against short current faults in electronic circuits. Application of such fuses is overcome where manually replacing fuses is difficult or almost impossible. For example, fuse in the nuclear system or in the aerospace system. Dear sir, thanks for watching.
I think you have got some basic idea regarding different type of fuses. Now we'll continue with the next component of power panel, that is contactor. Mostly, whatever the connection is going to be done to the machine to the supply, that is being done via this contactor. Because in a normal single phase supply, we can directly connect the motor to the supply. But in case of three phase, we need some protection. That's why instead of supplying the current directly to the motor, we are just providing some protection through these contactors. Okay, these contactors have their own relay which will just sense the current in the circuit, because mostly we are going to switch all the three phases simultaneously. So that's why we need a contactor. The complete contactor, if you see its internal structure of the contactor, you will have the contactor will contain all these three lines with neutral terminals. Okay, and they will have a parallel switch. So one relay will be there in the contactor, which will continuously sense the current in each line and neutral. So if that current is exactly equal or less than the rated value, whatever you set the relay, so means that is set for the motor. So accordingly, we'll set the current value of the relay. So if that is less than or equal to that amount of current, then it will allow the switch to be on. If the current will be more than that, so definitely the relay will sense that one and it will disconnect the switch. Okay, so just if protection, one kind of protection automatically. Okay, so because we are going to deal with high current, high voltage, in this motor may be damaged if the current will be very high. So that's why we have to give protection to the D-line. So there's a costly equipment. So we, and also the process which is being done by this motor is a sophisticated one. So that's why we need some additional protection, and that's why we are supplying power through conductor. Further, we'll also see the demonstration of conductors, how conductors have been connected. So particularly during the motor case. at the end of this particular experiment, we'll see the demonstration of different kind of conductors, particularly while we'll go to switch on the motor by using stator. We'll have either forward, backward starter, star, delta starter, or direct online starter. So they will be done through these contactors. Okay, we'll check that one again. Now let us move forward. Okay. Inside the contactor, you will have some relay, and that relay may be simply a control relay, or that may be a magnetic relay. That might be one thermal relay or overload relay. So thermal relay, it will just sense the ambient temperature. If that is suitable for the motor's operation, then it will continue the circuit. Otherwise, it will give command to break the circuit. Similarly, overload relay, if the motor will be overloaded, so definitely that will be sensed by the overload relay, and it will simply switch up the supply. That is, motor will stop. Otherwise, the motor winding may overheated and may be damaged. Okay. So likewise, the most important part of this power panel is the timer, because in industry so many processes are being regulated by time. So for that we require a timer which will be centrally located at the panel itself. In that way we can take the help of this timer for automatically operating some devices. For example, while we are going for star delta starter of a induction motor, three-phase induction motor. So normally what happens, initially the motor needs high torque just to start. Okay, and if we are going to connect it through your star connection, sorry, if you are going to connect it through delta connection, then what will happen? The motor will down and it will draw huge voltage and huge current that may damage the motor. So that's why what we are doing, during starting of the motor, we only connect the star network. Once the motor starts, then we are just change the connection from star to delta connection, and this conversion requires at least means 10 to 15 seconds, and that 10 to 15 seconds we will measure that 10 to 15 seconds automatically how the switching will be done. So that is being done by this timer. So the timer will be set for specific operation. Suppose we have set the timer to 10 seconds. So what will happen? The contactor, the delta star connection will be there for while we will initially switch on the main contactor and star contactor. They will be switched on up to 10 seconds. After 10 seconds, that star contactor will switch off and delta contactor will be on. So further the motor will operate on delta mode. Likewise, this timer is also having some more applications in power panel, because so many relays, they are time-based relays. Okay, so they also depend upon the time counting. So this is simply a counter which will help counting the time for those devices for automation and automatic operation. Apart from that, there are annunciator. Annunciator are simply just like the alert system, or you can say alarming system, where if we'll see the entire industry is a large load distribution area, so where there will be several motors are operating in several sections. So if there will be anywhere, there will be a problem, a fault occurs in any device or any part of the factory. So definitely it should be known to the control engineer. So control engineer will be in the control room. So to just for his information, there will be one annunciator on the panel. So what will happen? If there will be any fault in any zone, that will be alerted by the annunciator. Annunciator will just give some signal, some alarm signal, like if there is a buzzer, it will buzzer, or some hooter is there, there will be some noise will be there, along with you can say siren will be there, along with the light will blink. Okay, so in that way it will just attract the attention of the operator, and you will see, okay, there is a problem in this section. You will try to resolve that problem. Otherwise, what will happen, if the same problem will persist in the system, that may damage the entire process, and that may also paralyze the entire industrial process. Okay, so that's why we require to get acknowledgement, and that is being done by the annunciators. Apart from that, the backbone of every power panel is the bus bar. So just like we want to connect so many motors or so many loads to the supply, so we have to maintain one bus bar. So particularly bus bars are nothing but the copper and aluminum strips. Just like here you see R, Y, B and neutral. The bus bars are there. here also copper bus bars, and here aluminum bus bars are used. Okay, so where you can comfortably fix the supply, and there will be no kind of sort, you can say, sparking will be there, a loose connection will be there, so that there will be arc formation will be there. Okay, and that could not be happen, and air ionization will not be happen if we'll go for this farm type of thing, the connection. So that's why we require the bus bar arrangement, over which the conductors have been directly mounted. And this is human machine interface. Mostly while we are going for automation process, we use some software and some interfacing devices which will directly deal with the particular process. Okay, so some sensors will be there in the process that will be sent the information, and that will be fed to the processor, and this processor will just picturize that one through some content graphical processor. Okay, so this will be being displayed over a panel, and the operator will sit here and he can control the temperature, then air or fuel to that particular process by simply using this HMI, human machine interface. Here are the particular components or objects which normally used to just give a farm connectivity between the cable with the connecting point, because in single phase supply what we are doing, we are simply stripping out the insulation and directly we are just rotating the copper conductor over the joint point. But same thing could not be done for high current or high voltage circuit like three phase supply, because there will be huge current that may create some kind of arcing or something else. So to just avoid that scenario, we require some capping type devices, some objects which is known as ferrule. Okay, so they will be fixed to the conductor so that there will be no scenario of arcing or any spark or any strand will be get outside. There will be no such scenario. There will be safety connectivity, and the connection will be very firm. So that's why there will be no carbonation, so that will go for long duration. Okay, similarly some locks are used particularly for bolting purpose. Suppose we have to connect the conductor to the bus bar. Suppose these are the motors conductor and we should be fixed to the bus bar. So we are having bus bar and we can bolt it out, but for bolting we require this type of arrangement, and these are known as locks. These are the cable locks. Cable locks will be fixed with the cable. Now this will be fixed by bolt so that it will be a firm connectivity. There will be no loose connection, no sparking will be there, no carbonation will be there. Similarly, cable gland you might have seen in, if you are using any cable antenna, definitely the cable, while we are joining two cables, there will be a cable gland just made of in copper. Okay, so this gland will simply connect to cables. Okay, and it just provides protection so that there will be no strand go outside, signal will be leaked out. Okay, like that. And this already I have discussed. This is a fan or blower which is used in the front panel or back panel of the enclosure, just to provide proper ventilation and maintaining the temperature of the inside panel. Some protection protocols are there which should be followed by the industry while they are going for industrial wiring. Okay, so the codes and bridges are being available. You can follow. It is available in the manual. You can see that one. So while we are going for industrial wiring, we have to follow these protocols. Then let us start with what we are discussing. Let us go to the actual connection, how these contactors are being connected, particularly how the contactors are making and breaking the circuit and switching on and off the circuit, how that is connected directly to the motoring load. Okay, so here I have taken one example of direct online starter of a three-phase induction motor. Three-phase induction motor needs three-phase supply, and that three-phase supply is available in the line RYB. So through the MCB we'll get RYB, but here we have to connect one contactor. Okay, so that contactor will have one main contactor with relay. This is the contactor with relay. So based on the relay operation, it will be switched on or off. But while we require to start this one, so definitely we should have some additional relay to be connected to the motor, which is known as overload relay. So if during the operation the motor is becoming overloaded, so at that time what will happen? If it will be overloaded, it will try to draw more torque or more current to develop more torque to overcome this scenario. Because of that, high current will flow and that will create a mm, create the machine to be overheated and it may burn out. So to just provide protection to this, we should have an additional relay known as overload relay that will be mounted over the main contactor. Okay. So while we'll give the supply, so what will happen during the healthy condition, this contactor will just track this and this switch will be on. So finally the power will be available in the motor and motor will run. And while there will be any contingency, it will be overloaded. So at that time the relay will sense and overload relay will sense and it will disconnect the circuit so that no current will flow to this one. Okay. And exactly to energize this, there is start and okay, start button is green, stop button is red. So just let us go to the actual demonstration of connection that will be more clear to you people. So let us demonstrate the direct online starter using this video. Now we'll see another type of starter which is used for running the induction motor, that is star delta starter. So normally the logic behind it that initially we try to operate the motor using simply delta star. Then while it will be initially operated through delta, and it will continue till the end. So what will happen, it will draw inner current, and that inner current will damage the particular motor. So that's why initially we try to operate the motor in a star connection, star mode, because in a star mode low means less voltage, so low current will be available. And while the motor starts running at its rated speed, so once the motor starts, then we'll change the mode of supply from star to delta. In that mode, it will comfortably operate with a full load operating condition. Okay. So how the connection is done and what is the logic behind it, everything is discussed in one video. Just go through that. That will help you to understand how the star delta logic is used and how the star delta starter is being used to operate the machine.
Hey there guys, Paul here from the engineeringmindset.com. In this video, we're going to be learning how star delta starters work for three-phase induction motors. Remember, electricity is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Now this is a real-world star delta starter, and by the end of this video, you'll be able to tell me what each part does and how the whole system works together. Now for this video, I'm going to be using the old red, yellow, blue color coding for the phases, simply because I think it's easier to see. However, I will also show you versions with colors used in the US, EU, UK and Australia a little later into this video. Three-phase motors are used in almost every commercial and industrial building. have three separated coils which are used to produce a rotating magnetic field.
Okay, students, now am I available to you? Is the screen visible to you?
Yes, sir.
Okay. So shall I start from the beginning of this particular video?
Yes, sir, because the voice is not clear.
It is dangerous and can be fatal. You should be qualified and competent to carry out any electrical work. Now this is a real world star delta starter, and by the end of this video you'll be able to tell me what each part does and how the whole system works together. Now for this video I'm going to be using the old red, yellow, blue color coding for the phases simply because I think it's easier to see. However, I will also show you versions with colors used in the US, EU, UK and Australia a little later into this video. Three-phase motors are used in almost every commercial and industrial building. Inside a three-phase induction motor, we have three separated coils which are used to produce a rotating magnetic field. When we pass an AC current through each coil, the coil will produce a magnetic field which changes in intensity as well as polarity as the electrons change direction. But if we were to connect each coil to a different phase, then the electrons in each phase will change direction between forwards and backwards at different times compared to the other phases. This means that the magnetic field will change in intensity and polarity at a different time compared to the other phases. To distribute this magnetic field, we need to rotate the coils 120 degrees from the last phase and then combine these into the motor stator to produce the rotating magnetic field. This rotating magnetic field will cause the rotor, which sits inside the coils, to spin, and we can then use this to drive fans, pumps, etc. On the top, or sometimes on the side of the motor, we have an electrical terminal box. I'll just move that box here to make it easier to see. Inside this electrical terminal box, we have 6 electrical terminals. Each terminal has a corresponding letter and number. We have U1, V1 and W1, and then W2, U2 and V2. We have our phase 1 coil connected to the 2 U terminals. We then have the phase 2 coil connected to the 2 V terminals. And then we have the phase 3 coil which is connected to the 2 W terminals. Here's a real world example of an induction motor's electrical terminal box. Now I'm going to test your understanding of this a little later into this video. Notice that the coil terminals are in a different arrangement from the top side to the bottom side. We'll see why that is in just a moment. We now bring in the 3-phase power supply and connect these to their respective terminals. We always connect the supply side to terminals U1, V1 and W1. Now for the motor to run, we need to complete the circuit, and there are 2 ways to do this. The first way is the delta configuration. For this, we connect across the terminals from U1 to W2, V1 to U2 and W1 to V2. This will give us our delta configuration. Now when we pass an AC current through the phases, we see that electricity flows from one phase into another as the direction of AC power reverses in each phase at a different time. That's why we have the terminals at different arrangements, because we can connect across and allow electricity to flow between the phases as the electrons reverse direction at different times. By the way, if you want to learn more about how 3-phase electricity works, then we've covered this in great detail in our previous videos. Do check those out, links are in the video description down below. Now the other way that we can connect the terminals is to use the star configuration. In this method, we connect between W2, U2 and V2 on only one side of the motor terminals. This will give us our star equivalent design. Now when we pass AC current through the coils, we see that the electrons are shared between the phases at the terminals. So looking again at this real-world example of the motor terminals, can you tell me which method is being used? 3, 2, 1. Correct, it's the delta configuration. The 2 ways we just saw of configuring the motor in star or delta are fixed methods. To change them, we have to physically cut the power, open the motor terminals, and then rearrange them. Now this isn't exactly practical to do. So how can we automate this? To do this, we need to use some contactors. Now they come in various designs, but if we look inside one, then the basic operation is just a switch that can either make or break a circuit to control the flow of electricity in all 3 phases simultaneously. So we take our main contactor, and then we connect our 3-phase supply to one side, and then we connect the other side to the respective terminals within the induction motor's electrical terminal box. We then take a second contactor, which will be used for our delta circuit, and we feed our 3 phases into this also. From here, we connect our phase 1 to terminal V2, which is the phase 2 coil. Then we connect our phase 2 to terminal W2, which is the phase 3 coil. And finally, we connect our phase 3 wire to the U2 terminal, which is the phase 1 coil. Now we take another contactor, which will be used for our star circuit, and we connect our 3-phase power into this. On the top, we just connect all 3 phases together. I'll just remove the casing of the contactors so that we can see what's happening inside. Now we start in the star configuration, and to do that we activate both the main and the star contactor terminals so that they close to complete the circuit. Now when we pass electricity through the circuit, the electricity passes through each phase and coil and then out through the motor terminals and into the star contactor where the path of the electrons is shared. This allows them to flow in and out of another phase as the direction of each phase changes. This star connection method will run for a few seconds before switching over to delta. For the delta connection, we disconnect the star contactor and then close the delta connection. This all happens very quickly. Now we have the electricity flowing in, but it splits direction. It flows into both the main as well as the delta contactor. The electricity in the main contactor path will flow into the motor coils, and the electricity which took the delta contactor route will flow to the opposite side of the motor terminals. Each will then flow between the different phases as they reverse direction. To control the changeover from star to delta contactors, we simply use a timer to control this. This will automatically change the configuration over after a set amount of time. Additionally, there are more advanced versions which will monitor the amps or motor speed. If you are in the US, then you might find these colors being used. This is for a 208 volt 3-phase supply, but the colors will be different if you're using a 480 volt 3-phase supply. In the UK, EU and Australia, you'll find these colors used for the phases. If you're in the UK, then you're probably still going to come across versions with the red, yellow, blue colors being used. This is an old, outdated color system, but old installations are still going to exist. So coming back to this real-world photo of a star delta starter, can you tell me which part is which? 3, 2, 1. Correct. This is the main contactor, this is the delta contactor, this is the star contactor, and this is the timer. Notice on the star contactor, they've just connected 2 wires into the same terminal to create that star point. So why then do we use star delta starters? We use the star delta starter to reduce the inrush current when the motor starts. When a large induction motor starts in delta, their starting current can be over 5 times higher than the full load current which occurs when the motor stabilizes and runs normally. This huge surge in current will cause lots of problems. The building's electrical system will be hit by this sudden large demand. The electrical infrastructure will rapidly increase in temperature, leading to component failure and even electrical fires. The sudden large demand causes voltage drops throughout the building's electrical system. This can be visually seen because the lights will dip. This can cause many problems for sensitive equipment such as computers, servers, and safety systems. So to reduce the starting current, we simply need to reduce the starting voltage. The star configuration will reduce the coil voltage to around 58% compared to the delta configuration. A lower voltage will lead to a lower current. Current in the coil, while in star configuration, will be around 33% of the delta configuration. This will also lead to a reduction in torque. The star configuration torque will also be around 33% compared to delta. So let's look at a simplified, basic example of what's happening here to understand it further. Now let's say we have the motor connected in delta with a typical European supply voltage of 400 volts. That means when we use a multimeter to measure the voltage between any 2 phases, we will get a reading of 400 volts. We call this our line-to-line voltage. By the way, if you don't have a multimeter, then I highly recommend you get one for your toolkit. It's an essential piece of kit for any electrical fault finding and building your understanding of electricity. Links down below for which one to get and from where. Now if we measure across the 2 ends of a coil, we again measure the line-to-line voltage of 400 volts. Let's say each coil has a resistance or impedance, as this is AC power, of 20 ohms. That means we will get a current reading on the coil of 20 amps. We can calculate that from 400 volts divided by 20 ohms, which equals 20 amps. But the current in the line will be different. It will be 34.6 amps, and we get that from 20 amps divided by the square root of 3, which gives us 34.6 amps. That's because the phase is connected to the 2 coils. Now if we look at a star configuration, we again have a line-to-line voltage of 400 volts. We see that if we measure between any 2 phases. But with a star configuration, all our coils meet at the star point or the neutral point. It's from this point that we can run a neutral line if we need to. So this time, when we measure the voltage across the ends of any coil, we get a lower value of 230 volts. That's because the coil isn't directly connected between two phases like the delta version was. One end is connected to the phase, but the other end is connected to the shared point or the neutral point. So the voltage is therefore shared and will be less because one phase is always in reverse. We can see the 230 volt reading by dividing 400 volts by the square root of 3, which gives us 230 volts. As the voltage is less, the current will be 2. If the coil is again 20 ohms of resistance or impedance, then the current is calculated by 230 volts divided by 20 ohms, which is 11.5 amps. The line current in this design will also therefore be 11.5 amps. So we can see with the delta connection, the coil is exposed to the full 400 volts between two phases, but the star connection is only exposed to 230 volts between the phase and the neutral point. So we can see that the star uses less voltage and therefore less current compared to the delta version, and that is why we use it first. Okay guys, that's it for this video, but to continue your learning, then check out one of the videos on screen now, and I'll
Okay, students, you might have got idea regarding the star delta starter and why initially the motor is run with star connection and later on per delta, just to protect the circuit which are connected in line with that, so that there should not be any voltage dip. You might have also experienced that same scenario. Suppose in the early morning you just switch on your water pump. At that time you will find instantly there will be a dip in voltage. You can find that the light, if there will be a incandescent lamp, it will glow a little bit dim. Okay, so that is only because of the starting of motor. Once motor starts, then it will be restored. But initially during the starting of motor, there will be little bit dip because it needs more current during the starting. So same thing happens if we are going to use the delta connection directly for supplying the motor. So instead of that, initially we start with star supply. Then once the motor starts, then we just change the supply from star to delta. Next is the forward reverse starter. That means sometimes we in industry we require that some process should be done in a forward direction and backward direction. Suppose we are having one process through which we want to coordinate the conveyor belt. It should go some steps forward and again some steps backward. So in that way, suppose we are supposed to perform the task. For that, we need our same motor to be operated in a clockwise and anti-clockwise direction for a certain duration. Okay, so that duration will be maintained by the timer, but issue is how we will make it change the direction. Okay, so for that we have to use this forward reverse starter. So just by changing the polarity. If it will be a single phase motor, then simply by changing the polarity phase to neutral, neutral to phase, we can change the rotation. But since it is three-phase supply, so how to change the polarity? By simply altering all the phase sequences by means of forward and reverse starter. Okay, so this is being done and that is being explained in next video. You just go through the video, you will find the excellent explanation. So particularly this video is in Hindi, so I think it will be very much means understandable by you people. Just see the video how the forward and reverse starter is being connected to the circuit.
हेलो फ्रेंड, आज की इस वीडियो में हम आपको रिवर्स फॉरवर्ड स्टार्टर के बारे में बताएंगे। इसकी जो वायरिंग कैसे करते हैं, इसके जो कंट्रोल वायरिंग होती है वो कैसे करते हैं, इसके बारे में अभी हम आपको बताने वाले हैं। तो अगर आप हमारे चैनल पर नए हैं तो आप हमारा चैनल सब्सक्राइब कर लें ताकि आपको हमारी हर आने वाली वीडियो का नोटिफिकेशन मिलता रहे। तो फ्रेंड, हम जो इसकी वायरिंग है इसके बारे में बताने से पहले मैं अभी आपको बता देता हूँ कि जो हम ये रिवर्स फारवर्ड होता है, रिवर्स फारवर्ड मोटर हम क्यों यूज़ करते हैं। ज़्यादातर हम लोग जो एलिवेटर होते हैं उसमें, या हमारी ओवरहेड क्रेनें लगी होती हैं और बहुत सारी चीज़ें होती हैं जिसके लिए हमें एक ही मोटर को रिवर्स और फारवर्ड चलाना होता है। तो उसके कंट्रोल सर्किट कैसे बनाते हैं तो ये अभी मैं आपको बताऊँगा। तो उसके लिए हमें क्या क्या चीज़ चाहिए होता है। ये एक हमें सिंगल पोल एमसीबी चाहिए होता है जो हमारा सर्किट को कंट्रोल करेगा, और उसके लिए दो हमें मैग्नेट कॉन्टैक्टर चाहिए होते हैं, एक हमारा रिवर्स के लिए और एक हमारा फारवर्ड के लिए। और एक हमें ओवरलोड रिले चाहिए होती है, ताकि अगर कोई हमारी मोटर ओवरलोड हो जाए तो उसकी प्रोटेक्शन के लिए हम ये ओवरलोड इस्तेमाल करते हैं। उसके कनेक्शन कैसे करते हैं ये भी अभी हम आपको बताने वाले हैं। और हमें दो ऑन पुश बटन चाहिए होते हैं, एक हमारा रिवर्स के लिए और एक हमारा फॉरवर्ड के लिए। और एक हमें ऑफ पुश बटन चाहिए होता है, जो हम सर्किट को मोटर को ऑफ करवाने के लिए एक ऑफ पुश बटन लगाते हैं। तो इसकी मैंने डायग्राम भी बनाई हुई है, तो मैं अभी आपको इसकी डायग्राम, जो कंट्रोल डायग्राम है, ये भी दिखा देता हूँ। ये देख सकते हैं कि मैंने पहले एक सिंगल पोल एमसीबी लगाया हुआ है, फिर नीचे उसकी ओवरलोड रिले लगाई हुई है, और फिर एक ऑफ पुश बटन लगाया हुआ है जो हमें सर्किट को ऑफ करने के लिए। और ये एक ऑन पुश बटन है जो हमारा मोटर की मोटर फारवर्ड चलेगी। और ये एक दूसरा ऑन पुश बटन लगाया है जो हमारी मोटर को रिवर्स के लिए चलेगी। और ये हम इसमें ये दो देख सकते हैं कि मैंने इसके दो एनसी पॉइंट यूज़ किए हुए हैं। ये इसकी इंटरलॉकिंग के लिए इस्तेमाल किए हुए हैं, ताकि अगर कोई हमारा मोटर फारवर्ड चल रही हो तो कोई सडनली हमारा दूसरा पुश बटन ऑन कर दे तो ये हमारी मोटर जो है रिवर्स ना चले, उसकी हमने इसकी इंटरलॉकिंग की हुई है। तो इसकी इंटरलॉकिंग के बारे में और दूसरी कंट्रोल वायरिंग के बारे में अभी हम आपको बताते हैं, इसकी कंट्रोल वायरिंग कैसे करते हैं। तो अभी मैं आपको इसकी कंट्रोल वायरिंग करके दिखाता हूँ। ये हमारे पास एक ड्राइंग है, इसके थ्रू हम ये बनाएंगे आज। फ्रेंड, जैसा कि अभी आप देख सकते हैं कि मैंने जो इसकी ओवरलोड रिले है वो मैंने इस कॉन्टैक्टर के नीचे लगा दी है। तो आपने वायरिंग करने से पहले जो ये देख लेना कि इसकी ओवरलोड रिले ये है वो इधर से फुल टाइट होनी चाहिए। जैसे कि अभी मैंने इसको इस कॉन्टैक्टर के नीचे लगा दिया है, ताकि कोई लूजिंग ना आए और हमारा कोई शॉर्ट सर्किट ना हो। तो इससे अगर कोई लूजिंग होगी तो हमारी मोटर को जलने का ख़तरा है। तो इससे पहले कि आप ये फुल इसकी जो ओवरलोड है इसको टाइट कर लें। तो अभी हम आपको जो इसकी वायरिंग है वो करके दिखाते हैं कि इसकी कंट्रोल वायरिंग कैसे करनी है। फ्रेंड, जैसा कि अभी आप देख सकते हैं कि जो मैंने इसकी मेन सप्लाई दे दी है, इसके अंदर जो हमारा एमसीबी था उधर से मैंने आउटपुट लेके जो हमारी ओवरलोड रिले है उसके एनसी पॉइंट पे मैंने दे दिया। अभी इसके एनसी पॉइंट से हम आउटपुट लेंगे जो हमारा ऑफ पुश बटन है। अभी ऑफ पुश बटन से आगे जो हमारा ऑन पुश बटन है उस पर हम इसकी वायर लगाएंगे। जैसा कि अभी आप ये देख सकते हैं कि मैंने जो हमारा एमसीबी था उसमें सप्लाई दी, लाइन दी, और उधर से हमने ओवरलोड में दी। और ओवरलोड से लेके अभी हम आउटपुट लेके जो हमारा ऑफ पुश बटन है उसमें देंगे, और उससे जो ऑफ पुश बटन से सप्लाई निकलेगी हमारे ऑन पुश बटन में जाएगी। तो ये अभी लगा के अभी आपको हम दिखाते हैं। फ्रेंड, जैसा कि अभी आप देख सकते हैं कि हमने पहले ऑफ पुश बटन तक सप्लाई हमने जो दे दी थी, अभी ऑफ पुश बटन से जो हमारी सप्लाई निकली है हमारे ऑन पुश बटन के जो हमारी इनपुट है उसके ऊपर गई है, और जो उसकी आउटपुट निकाली हमने, जैसे कि अभी ये देख सकते हैं जो हमारा ऑन पुश बटन था उससे हमने निकाल के एक तो हमने जो उसका कॉन्टैक्टर का होल्डिंग पॉइंट था उसको दे दी सप्लाई, और उधर से हमने जो ऑन पुश बटन था वो हमने K2 मतलब कि जो हमारा रिवर्स का कॉन्टैक्टर था उसके NC से निकाल के हमने जो फॉरवर्ड का कॉन्टैक्टर का A1 पॉइंट था उसके ऊपर सप्लाई दे दी है। जैसे कि अभी ये देख सकते हैं कि मैंने अभी ये इसका आउटपुट से निकाल के ये हमारा जो NC पॉइंट है, ये देख सकते हैं जो हमारा रिवर्स का NC पॉइंट है, ये देख सकते हैं NC पॉइंट है। NC पॉइंट से निकाल के मैंने इसको कॉइल को दे दी है, जो हमारी इसकी इंटरलॉकिंग हो गई है। और उधर से मैंने जो हमारा ये एक होल्डिंग पॉइंट है, ये देख सकते हैं जो इसके मैंने होल्डिंग पॉइंट दी हुई है, ये देख सकते हैं जो हमारी वायर आई हुई है जो हमारा ऑन पुश बटन से आई हुई है। तो अब ये देख सकते हैं कि हमारा जो हमारा एक सर्किट था, इस साइड का जो हमारा फॉरवर्ड का सर्किट था वो हमारा कंप्लीट हो गया। तो अभी जो हमारा रिवर्स का सर्किट है वो अभी हम आपको वायरिंग करके दिखाएंगे कि इसकी कैसे वायरिंग करते हैं। तो फिर इसके बाद हम आपको जो हमारा सर्किट है वो ऑन करके दिखाएंगे। फ्रेंड, जैसा कि अभी आपको मैंने बताया था कि जो हमारा दूसरा कॉन्टैक्टर था उसकी वायरिंग कैसे करनी है। जैसे अभी मैंने इसका होल्डिंग पॉइंट से निकाल के जो हमारा फॉरवर्ड का होल्डिंग पॉइंट देख सकते हैं कि मेरी वायर आई हुई है, और ये वायर आके हमारी जो पुश बटन था उसमें गई है, और उधर से मैंने उठा के जो हमारा रिवर्स का होल्डिंग पॉइंट था जो हमारा कॉन्टैक्टर है रिवर्स का, उसके हमारा जो A1 पॉइंट के ऊपर दे देंगे।
Okay, students, you might have got the idea how the connection is being done. So next we'll move to the experiment number 9, which is the connected part of this experiment number 8. Okay, so let me first discuss the theory of experiment number 9, then we'll move for the demonstration. Professor Chanakya Bhattasar is there in lab. He will give the demonstration of the equipment, particularly this control panel. Again, he will say regarding this contactors, star delta direct online contactors and main contactors. Then you will move to the control panel. You will just explain exactly regarding the different parts of control panel, and also you will give the demonstration by creating some fault, how the annunciator works, everything will be shown in that particular video. So till then, just let me connect to the next experiment PPT. Just closing the program. Specifically in experiment number 8, we have seen some part of the control panel. Now we'll continue the same with experiment number 9. In experiment number 8, you don't have any observation. You have to write the conclusion, what you have understood. Then you have to answer the quiz. Then let us move to the experiment number 9. So this is continuation of that one. Again, we'll go for the demonstration of same panel with the same apparatus, what we have discussed in experiment number 8. And here some new equipment you will find, that is one toggle switch. The toggle switch, you might be seen those switches in our day-to-day operation, specifically while we are getting some heating elements. Okay, so there we are also finding this type of switches. Mostly these are very normal switches. Only we are using the fan switches and the light switches. They are the low current switches, means capacity, low current capacity switches. But here, since they are being operated in high current operation, that's why its packaging is little bit different. This is a SPSP switch, which is very similar to the normal switch we are using for the bulb and fan. And this is SPDT switch, which is very normal to the staircase wiring switches or the go down wiring switches. Okay, so in SPST, if we'll switch it off, then it will be on. Down means off. Similarly, SPDT, it is having two on condition. The middle one is off. It will go to off. That will be on, and that will be connected to one circuit. And it will be means toggle down. So toggle down. So what will happen? It will connect to another circuit to make it on. Okay. So there are certain standards while we are going for this industrial wiring. We have to follow those standards. Okay, and we have to follow some procedures while we are going to design the panel. So accordingly, we can just uh, while we are going to manufacture some control panels, or somebody who some industry which is manufacturing the control panel. So for them there are certain guidelines with standard that is being provided by standard protocols, so they have to follow that one. Okay, so particularly while you are going to do some industrial wiring, just like domestic wiring, you have to first go for a sketch, rough sketch. Then you have to locate in sketch. You have to locate how which load will be means, segregated, and which load will be connected at which place. What will the tentative distance? What will the power rating? The electrical calculation. Everything you have to do beforehand. Then after that you have to decide what should be the size of the enclosure, what are the components will be used, how many relays will be there, how many contactors will be there. Okay, so all these things you have to decide after getting the complete sketch. So here sir will explain you regarding the contactors.
Okay, dear students, so today we are going to see the performance of contactor. Contactor is an integral part of any motor starter panel. So experiment 9 is the different types of panels that we are going to use in case of induction motor. But the heart of any control panel is the contactor. How the contactor works, what is the logic behind the operation of contactor, what do you mean by the contacts, everything we would like to see in this experiment. At the same time, the control circuits, what we are going to see in case of experiment 9, the star delta starter and the DOL starter, in our laboratory we have a setup for them. So we will also show you the operation of direct online starter and star delta starter from the contactor perspective point of view. Here we are not going to put any real motor, but this is just the control logic understanding for this contactor based motor panel. So now let us concentrate on this piece of article. The thing what you see over here is nothing but the contactor. This is the contactor. This contactor is a three-phase contactor. Now, three-phase contactor in a sense that one side there will be incoming, other side there will be outgoing. Now, here at the top you see there are some indications that whether the contactor is on or off. Now, on the side of contactor, here where I am pointing, this is the coil. This is the terminal of the coil. So this is first terminal, and on the opposite side there will be another terminal of the coil. So there are two terminals of a coil. A coil is single between all three phases. Now if you see the nameplate of this contactor, now if you concentrate on the nameplate of this contactor, the rating of the contactor is mentioned over here. So it is a 415 volt contactor in this case. So it's a motor contactor. Now let us see the operation of contactor. So now what we will do, we will energize this coil by a 230 volt supply, and when this coil terminals, one terminal is here, another terminal is here. So whenever we give 230 volt, you will observe here that this contactor will pick up. So whenever the supply is given, it will pick up, and whenever the supply is released, it will release itself. So it is converted itself from normally open contact to normally closed contact, and once you release it, it will be from normally closed to normally open. So now let us see the operation of contactor. So now Ghanshyam bhai has a series test lamp. Now this series test lamp, whenever we use this series test lamp has a voltage. So he is putting a contacts on a contactor. Now you see the contactor is operating. There is a chattering voice coming. So he is continuously touching and let's say breaking the contact, making the contact and breaking the contact. So when the supply is connected, it will be picked up. Whenever you release the supply, it will release itself. So there is a spring coil mechanism inside it. Okay. Now these contactors are used in starters. So now here you see there are two setups which are there. This setup is a star delta starter setup. So here you see there are total three contactors. Contactor number 1, contactor number 2 and contactor number 3. So there are three contactors over here. This is the timer to set the timing from star to delta transition, and this is the overload relay. Meanwhile, make sure that this is just the control logic setup. We are not going to use any real motor over here. We will just show you how the motor is connected in star and delta from the contactor point of view. Now if you come over here, the second setup is for a direct online starter. In direct online starter, as we have seen earlier, you only require one contactor. So here you require one contactor over here. One is the incoming supply, one is the outgoing supply. This is the start push button, this is the stop push button. These are the coil terminals, these are the normally open contact, these are normally closed contact, and so on. So now we will see the performance of this direct online starter contactor. So whenever we press green button, that time the contactor will pick up and the lamp will glow. That means right now in place of motor, we have emulated the representation of motor as a lamp. So now I just turn on this starter. Now it is on and you see the lamp is glowing. So assume that this is in forward direction. Likewise, if I interchange the polarity of the RYB phases, reverse the polarity, then it will be RBY and it will something like a reverse rotation. But right now this is only the control circuit, and control circuit is running on 230 volt supply. So only one phase supply we are using over here to just help you to understand the contactor logic. Now I turn it off. So when I press stop push button, the contactor is off. Now let us go to star delta operation. In case of star delta operation, as I mentioned earlier, three contactors are there, 1, 2 and 3. One is a main contactor, one is a star contactor and another is a delta contactor. So whenever we press start button, that time main contactor and star contactor will be picked up and the motor is running in star. This is the timer, so timer will start counting as soon as you turn on the supply. Right now if you see, the timer arrow is at 10 seconds. So this timer is going to typically operate between 8 to 10 seconds, and by 10 seconds the star contactor will turn off and the delta contactor will turn on along with the main contactor. So now let us see the operation. So you concentrate on the position of the starter, which two contactors are going to pick up. So you see this contactor and this contactor are picked up. These two contactors are picked up. Timer has already started. So now you see another sound. So here this contactor has turned off and this contactor is also on. So this is the main contactor, this is the star contactor and this is the delta contactor. Initially star contactor and main contactor were picked up for 10 seconds, and after 10 seconds star contactor turned off and the delta contactor turned on. We will repeat this experiment for higher time. So let us turn off. Let us increase the time. So we increase the time from 10 to 20 seconds and now we again repeat. So now you observe these two contactors will picked up and the timing has started. So approximately after 20 to 22 seconds, this contactor will turn off and this contactor will turn on. So the motor will fall in delta connection. So let us wait for the time to get over. You observe this two position. Yes. Now this is in delta. So the delta contactor has picked up. Star contactor has turned off. Main contactor is as usual. It is permanently on. So this is the operation of star delta starter contactor logic. Thank you.
Okay, students, so you might have got the basic operation and demonstration of star delta particular contactor, but we have already seen in the previous experiment. We have seen the contact connections and all those operating. Okay, so here there have been demonstrated that operation using a simple small demonstration. Similarly, here in this experiment, we'll try to see the detailed operation of those panels what we are going to design. Okay, so mostly while we are going to design, as I have told, we have to go for the consumer side and you have to check the entire means it's a total area which is going to be energized. Okay, so accordingly you have to make a map, or you can say sketch. From that you can get the idea of how many loads are going to be connected, what are the rating of loads, what will be the electrical power requirements. So everything you have to calculate. After that you have to think of the mechanical design of the enclosure depending upon the power rating, total power being going to be handled by the particular premises. You have to decide how many circuit components will be there. So accordingly you have to see what should be the size of bus bar, what number of components will be there. So accordingly the mechanical design of enclosure will be decided. Then we have to provide mechanical paint or process depending upon the industry for which it is being designed. Then we'll go for the power and control wiring. Okay, similarly we should also after design of that we should go for electrical testing of that one. Okay, and after testing we'll dispatch and we'll go for the installation and commissioning of the particular control panel. Then if the panel is suitably commissioned, then we will think of over the warranty of that one. Okay, so mostly while we are considering the electrical circuits, or particularly the industrial loads, the most loads are the heavy motors, 3-phase motors or induction motors, where what we need, we have to suitably start them and go for the smooth operation. If there will be any problem, any loading issue, any fault will be there, so it should be protected from the control panel itself. Okay, so for that we have to understand how the particular components are going to be working. Okay, so for that sir is there to just give you a demonstration of those by taking a sample motor. So sir will try to demonstrate you by creating fault how the annunciator works and how the motor can be changed its direction during the operation. Okay, everything. So let's see that one.
Okay, good morning students. So today we are going to see the performance of experiment number 9, which is basically the contactor logic to be applied for motor control center. We are aware that various motors are used in industry, and one of the most popular motor is induction motor. Now induction motor cannot be started directly from the supply. We have to provide a starter to them, because starter will limit the inrush current to the induction motor. So to see how the starter look like, we would like to see the panel which is there in our laboratory. So we will see the layout of the panel, and after seeing the layout, we will see the operation of the panel. So now if you see, this is the front panel view. This is the front view of the panel. Now I will explain each one of the thing one by one. This is the current meter. This is the ammeter, which measures the current drawn by the panel and subsequently the motor. This is the voltmeter, which measures the line voltage that we apply to the motor. So it will measure the voltage between RY phase, YB phase and DR phase. It is the line voltage. Now here you see there are 3 color indications: red, yellow and blue. So these are 3 LED type indicating lamps which will indicate us that the supply is live. So that is for supply indication. These 2 are the selector switches. This is the ammeter selector switch. This is the voltmeter selector switch. Because right now we are working with 3-phase system. So, but the meters are single. So if I put this switch on RY, then it will indicate RY line voltage. If I put the switch on YB, it will indicate YB line voltage. If I put it on BR, it will indicate BR line voltage. And subsequently R phase current, Y phase current and B phase current. So the selector switches are for that purpose. Now here you see there are 3 more LED type indicating lamps. Inside this panel there are 2 starters. One is the direct online starter and second one is the star delta starter. So these 2 LED type lamps are for 1 HP, 1 horsepower DOL. DOL means direct online, and then it is written forward on. So when this lamp is glowing, that means the motor is running in a forward direction, let us say with RYB phase sequence, and when this lamp is on, the motor will be running in a reverse direction, that means it is the RBY phase sequence. So this is for forward indication, this is for reverse indication. But make sure that whenever you would like to reverse the rotation of the machine, first of all you have to stop the machine and then it will rotate in the opposite direction. This lamp is for star delta starter. So star delta starter, whenever it is on, this lamp will be glowing. Now these are the push buttons to start and stop the motor. So green color buttons are for start and red color buttons are for stop. So these 2 green buttons are for direct online starter forward rotation and reverse rotation, and the stop button is a common button, whereas this button is for stop button for star delta starter and this button is for the starting of star delta starter. Now these 4 switches what you see, these are known as toggle switches. Now what is the purpose of toggle switches over here? So let us first of all see this point over here. So this in between the part what you see, that is called annunciator. Now annunciator is for the purpose of fault indication. Whenever there is a fault in the machine, the operator must know what is the type of fault, and at that time the panel should not work or the motor should stop. So whether the fault is there or not, that will be indicated by these windows. So in our system we are creating the fault artificially, and to create that artificial fault we are using these 4 toggle switches. So these 4 toggle switches will will be turned on, and these 4 windows will be glowing, and it means that there are 4 different faults which are created. Then we will see that first of all operator has to acknowledge that fault, because without acknowledging you cannot reset this, and after acknowledging the blinking of the LEDs will be off, and once the blinking is off we have to work at the fault location, we have to clear the fault, and after clearing the fault we have to reset this system. So this is what is the front layout of this entire panel. These are the naming specification of the panel, and the manufacturer name is mentioned over here. So now we will see the inside view of panel. Okay, so right now we have opened the panel, and now you see this is the back view of the front door what we have just seen. So these are the back views of voltmeter and ammeter. This is the back view of microprocessor based annunciator. Depending on the settings on this switch we can configure the various faults, and these are the points where you can give the information to the annunciator that a particular type of fault has occurred. These are the LED indicating lamps. These are the selector switches, the backside connections are there. These are the start stop push buttons are there, and these are the toggle switches are there. So this is completely the backside wiring, and you see every wire is particularly color coded, as well as there are ferrules on it. On every wire there are certain numbers which are written, and these numbers are helping us to track or to trace the wire from where that it is going from which point to which point. So that is the purpose of putting the ferrules over here. Now if you see the connection over here, this is completely a starter panel. So if we see at the bottom this is the incoming supply. See, panel is basically a device which is coming between the supply and the motor, because panel is the one which is going to control the performance of motor. So this is the incoming terminal. We have to give 3-phase supply to this panel, and from this panel there are 2 motors what we are going to drive. So these 3 terminals are for direct online motor. We are going to use 1 HP motor for direct online, and this is for star delta motor. Star delta motor is of 2.2 kilowatt. Now all these are basically the controlling circuitry. So if we go one by one, this is the main MCB. This is the main MCB. Once we turn on this MCB, then and then the main incoming supply will be available. These 2 are the MCB for DOL starter and star delta starter, because we can control both of them simultaneously, or independently also we can turn on their supply. These 3 are the current sensors. These 3, the 3 coils what you see over here where I am pointing right now, these 3 are the current transformers. So current transformers are there to measure the current, and since we are using the AC current over here, these are known as the current transformer. Now you see there are 4 relays over here. These 4 transparent relays what you see with an LED. These 4 relays are basically that fault indicating relays what we are going to trigger through toggle switches. So whenever I turn on the toggle switches, these 4 LEDs will glow, and it indicates that there is a fault over here. These are the cartridge type fuses. These are the fuses which are used in a system. So this is 1 fuse, 2nd, 3rd, 4th and 5th. So these 4 and this are the fuse in this entire panel. The purpose of fuse you already know. Now this fuse is for protection of CT, and this fuse is for the protection of relay. Now if you see at the bottom there are different types of contactors. All these 5, 1, 2, 3, 4 and 5. These 5 are the contactors, and these points where I am pointing 1, 2, 3, 4 and 5, these are the add-on contacts of a contactor. This is the timer. This orange color is a timer. It is a 30-second timer. These two, what you see at the bottom of the contactor, they are overload relays. The purpose of contactor is to turn on and turn off the connection. So we will see the operation of contactor separately, but right now just to introduce it, I say that this is nothing but the contactors. These two contactors are for direct online starter, and these three contactors are for star delta starter. So now we will see the performance of this machine. So okay, so dear students, now we have turned on the main supply. So now you see there are three LED indicating lamps are now glowing, red, yellow and blue. Now we are going to start the direct online motor. Now here you see, this is the motor. This is the 1 HP 3-phase induction motor. Since this is 1 HP motor, we can afford to start on direct online basis. So here one flap is also connected. That flap will indicate the direction of the rotation. So one time we will show you that the motor is rotating in forward direction, and after that we will show you that the motor is running in reverse direction. Now this meter, what you see right now, this meter is indicating 0. This meter is a current measurement meter. So whenever the motor starts, this meter will indicate the current, and this meter is a speed indicating meter. So Ghanshyam Bhai will put this meter on the motor, and at that time you will see what is the speed of the machine in RPM. So now let us turn on the motor. So now what I want you to let's say concentrate is, you just concentrate on the rotation of the motor, because right now I am starting the motor in the forward direction. So let me turn on. So now all the MCBs are on. So now I am turning the motor on. So now I am pressing forward. Now keep the video over there for flap. Flap pe rakho so that we can see the rotation. So see, motor is now running. Right now it is drawing 0.6 ampere current. So current meter is indicating 0.6 ampere, and RPM what you see, 1472, 1496, 1498 RPM, revolutions per minute is right now happening, and current drawn by the motor is 0.6 ampere, because right now the motor is running in no load condition. Now I turn off the motor, and then I will press the reverse button. So you will see the motor will start rotating in a reverse direction. So let us stop. Now the motor stops. So you see the RPMs are gradually reducing, and now you see the rotation. It is anti-clockwise. It is right now anti-clockwise. Now I press the reverse button, so now it should start clockwise. So let us see the reverse button. So now I am pressing reverse. Now you concentrate over there as far as the direction. So now, as we have observed, motor is now running in a clockwise direction, and again the current value is same, 0.6 ampere, and again the speed is approximately 1496 to 1498 RPM. So this is the operation of DOL starter with both forward direction and reverse direction. The design of the logic is designed in such a way that while the motor is running in one of the direction, if I press any other button, then the motor will not rotate in reverse direction. So it's an interlock between forward and reverse. Thank you. Okay, so dear students, now we are going to see the second part of this experiment. Now we would like to turn on the star delta starter. What is the purpose of star delta starter? The purpose of star delta starter is, initially the motor will work in a star connection, and after some time, the time which is set by the timer, the motor will put in delta condition. Now what is the reason behind that? The reason behind that is, our nominal supply of 3-phase, the lowest 3-phase supply in India is 400 volt line to line. So now when we see the delta connection, you are very well aware that in delta connection, line voltage is same as the phase voltage, and we are concerned with what is the phase voltage that we would like to apply to the motor. So initially, if the motor is in delta connection, then the phase voltage of the motor will also be 400 volt, and motor will start drawing enormous current. So that enormous current will affect the other apparatus which are connected on the same supply, and they will face the voltage dip. So to avoid that situation, what we want motor to give less voltage initially, and after the motor picks up a speed of around 70% of its rated speed, that time we would like to apply the full voltage. So to give less voltage to the motor initially, what is done over here is, initially the motor is kept in star connection and it will stay in a star connection for 20 seconds, and after 20 seconds the motor will put in delta connection. So in performance you will observe that whenever the machine is in star connection, the supply voltage is 400 by root 3, which is approximately 230 volt, and after the timer operates, after let's say 15 to 20 seconds, the motor will fall in delta connection, so that time entire 400 volt is applied to the motor. So that you will observe from the various readings and the performance of the motor. Now this is the motor, this is the induction motor, it is the 2.2 kilowatt induction motor, and this is the nameplate of the induction motor. You see there are various information which is given for this. Supply voltage is 415, RPM is 1440, the frame, the class, the rated current of the motor is 4.5 ampere, and so on. Now this is the terminal box of the motor. Since this motor is a star delta starter operated motor, there are total 6 terminals which are required for the motor. It is not a 3 terminal motor, it is a 6 terminal motor. So R1, R2, Y1, Y2 and B1, B2, and whether they are connected in star formation or they are connected in delta formation, that is decided by the starter. Okay, so now we are going to see the performance of star delta starter. Now I am going to turn on the supply to the star delta starter. So you have to observe the readings over here. आपको यहाँ पे रीडिंग ऑब्जर्व करना है. This is the voltmeter which is indicating the phase voltage of the motor. Initially the motor is in star connection. So in star connection the relationship between phase voltage and line voltage is 1 by root 3. So our line voltage is approximately 400 volt. So the phase voltage will be 400 by root 3. So it is approximately 220 to 230 volt. So initially for 10 to 15 seconds you will see that this meter is giving you a reading of 230 to 220 volt, and then that time the current drawn by the motor is given by this meter, and after 10 to 15 seconds you will find that this meter will indicate 400 volt because that time the motor is in delta connection. In delta connection line voltage is same as the phase voltage. Line voltage is around 400, so the phase voltage is also 400, and the current drawn by the motor will increase. So now let us see the operation. So now I turn on. Now I request Asaram Bhai to look at the meter. So now I turn on. Now you concentrate on the meter. You also see the noise coming from the motor. Right now 236 volt and 0.64 ampere is the current drawn. Now after some time you see there will be 400 volt. So just concentrate on it. Yes, now the motor is running in delta connection. Now you see the voltage is around 408 to 410 volt, and the current drawn by the motor is around 2 ampere, and the speed of the motor is 1494 rpm. Now the motor is running at a full speed because the motor is getting the full rated voltage. Initially at the time of start you must have observed that the speed of the motor is around 1000 or 1100 rpm because the voltage given was around 230 volt. But now we are applying the full voltage, and hence the motor is running at full speed, and this is the no load current drawn by the motor. Thank you. Okay, so now after seeing the performance of DOL and star delta starter, now we would like to see the performance of annunciator. Here we are artificially creating 4 types of faults because in actual field the faults are created like overload fault, over temperature fault, over voltage fault, under voltage fault, but at a laboratory level we would not like to create such faults, but on the contrary we would like to create the artificial fault. So right now you see none of the windows are glowing. Now I am giving the artificial faults by turning on these toggle switches. So I am turning on all 4 toggle switches, 1, 2, 3 and 4. So now you see all 4 windows are now glowing. You can also write a type of fault inside this by putting a paper and writing on the paper that it's a overload fault, over voltage fault, under voltage fault, over temperature fault. Now you see, I would like to reset. I would like to reset the fault, but it is not resetting. Why? Because first of all, operator has to come. Ideally, with annunciator, there is a siren also, because we need to protect the lives of human. So in that condition, in case of a fault and if there are chances of any human fatality or injury, all the operators who are working with the motor should get alerted. So that is why there is a siren along with the annunciator, but since this is for a laboratory purpose setup, we have not kept the hooter. Now here, right now the fault has not cleared, but I try to reset the annunciator. So in case if any operator would like to reset before clearing the fault, annunciator will not allow it to do so. So what is the first job that the operator has to do? Operator first of all acknowledge the fault. So whenever I press the acknowledge button, the blinking will stop. See, now I have pressed acknowledge button, so the blinking has stopped. Now I would like to reset, but as soon as I press the reset, it is not resetting. Why? Because the faults are still uncleared. So first of all, we have to clear the fault. So now I go to the toggle switches and I clear the fault. So 1, 2, 3 and 4. All four faults are cleared now, but still the annunciator windows are glowing. So now since all 4 faults are cleared, now I can press the reset button and now the fault is cleared. So this is the typical mechanism which is followed in industry in case of fault. Thank you.
Okay, students, this is all about experiment number 8 and 9. So in this experiment also, like experiment number 8, there is no observation table. So only you have to write the conclusion, what you understand from the experiment. Then you have to go for the quizzes. You have to answer the quizzes. Okay. If there is any doubt or any query, you can ask in between. Yes, we are having 2-3 minutes. We can discuss regarding your doubt. Any support you need, any doubt, you can ask me. If there is no query, then I can wind up the session. Thank you very much for joining the class. Yes, in chat box something is written. Let me check that. Yes, exactly. The today's class video, is not being accessible to me because I have login through ma'am's account. So whatever recording will be there, so that will be passed to the ma'am's account. So let ma'am come back to the college. Okay, by Monday. So you just contact ma'am. Ma'am will share you the particular class video. Okay. If any doubts or any queries there is, then I will attend. Otherwise, we'll wind up the session. You may leave the session and join your next class. Thank you very much for joining the class. Have a good day.
Thank you, sir.